Hey everybody! In this video, we'll explore how to find the derivatives of a function, which is a key concept that helps us understand the rates of change and slopes of curve. So, let's dive in. I guess you're wondering, what are derivatives? Is it hard? Does it involve too much math? Is it complex? Before we dive into solving, let's understand what a derivative is. Simply put, a derivative tells us how a function changes at any given point. Think of it as the function's rate of change or slope at a specific point. Moving on to the next part, here is the list of the common derivative rules. For the power rule, this is the most commonly used rule. It tells us that if we have a function in the form of x raised to n, its derivative is nx raised to n minus 1. So for any term with x raised to a power, we just multiply the exponent by the coefficient and subtract 1 from the exponent. For the constant rule, the derivative of a constant is always 0. No matter what the constant is, its rate of change is 0 since it doesn't change. For the constant multiple rule, if you have a constant multiplied by a function, you can just take the derivative of the function and multiply it by the constant. For sum or the difference rule, if you have a multiple term if you have multiple terms added or subtracted, you can take the derivative of each term separately, then add or subtract the results. Now, let's apply these rules to solve some example problems. First, we will find the derivative of f of x equals x cubed minus 4x plus 2. To start, we break the function into separate terms. We have three terms, x cubed, negative 4x, and 2. For each of these, we will apply the appropriate derivative rule. For the first term, x cubed, we use the power rule. We bring down the exponent and subtract 1, so it becomes 3x squared. The second term, negative 4x, is linear, so we apply the power rule again, where the exponent of x is 1. Bringing down 1 gives us negative 4 because x raised to 0 is equals to 1. For the constant, which is 2, the constant rule tells us that its derivative is 0 because constants don't change. And now, combining these results, we get f prime of x is equals to 3x squared minus 4. Now let's try another example. Here we are asked to find the derivative of g of x equals 5x raised to 4 minus 2x cubed plus 7. Again, we will break this into three terms. So now we have 5x raised to 4, negative 2x squared, and 7. For 5x raised to 4, we apply the power rule. We multiply the coefficient, which is 5, by the exponent, which is 4. This gives us 20x cubed. For negative 2x squared, applying the power rule again results in negative 4x. For the constant, which is 7, the constant rule tells us that the derivative is 0. So, combining our answers, we get g prime of x equals 20x cubed minus 4. In this tutorial, we explored the fundamental rules of differentiation, which allowed us to efficiently find the derivative of functions by breaking them down into manageable parts. The power rule simplifies polynomial terms by bringing down the exponent and subtracting 1. The constant rule shows that the derivative of any constant is 0, while the constant multiple rule lets us factor out constants before differentiating. Additionally, the sum and difference rule allows us to differentiate terms individually and then combining the results. These examples highlight how differentiation provides the rate of change or slope of a function at any point, which is a crucial concept in calculus used in motion analysis, optimization, and understanding graph behavior. By mastering these basic rules and consistently practicing with various functions, we build a strong foundation for tackling more complex calculus problems.